Okay, we're going to have a outside, inside, and inner portion. Outside is the bracket cubed, followed by secant parentheses, and followed by the 2x to the fifth. Okay, we take turns with each derivative, making sure that each derivative occupies a separate space from each other. Okay, power rule for bracket cubed, 3 bracket squared. Okay, and then followed by secant's derivative. Secant's derivative is secant u tangent u. Okay, and what goes inside the parentheses is going to be the 2x to the fifth. And finally, the inner function's derivative. Okay, so this is fine, but I can go a little further if I wanted to. Push all the coefficients out in front. The non-trig out in front, and I can combine the secants together.
Mr. Yang?
Yes.
So if we get to that part correctly, but we clean it up wrong, are we going to get lose points?
It depends on where you're making a mistake.
Okay.
But at the most, it's very minor because I see the correct work in front of me. I would, okay. Yeah. So yeah, just know that you can leave your answer like this, but I want you to recognize what a simplified answer could look like. That's all. Okay, any questions with one? Okay, number 2. We see that it says evaluate y prime of 2 pi. So that means we have to find the derivative first, and then we can find the slope of evaluate the derivative at 2 pi. So replace all the x values with 2 pi once you get to the derivative. Okay, the first thing is quotient rule, right? We need quotient rule, numerator and denominator. Okay, f prime times g minus f g prime all over g squared. Okay, so we can think of the sine of x over 2 as sine of 1/2 x, if it makes it easier to think about what's happening here. So the derivative for sine of u is going to be cosine of u times u prime. So the derivative of 1/2 x is 1/2. The 2 is going to stay. It's my f prime. Okay, times the g function minus back to the f and then g prime. So secant's derivative is secant x tangent x times 1 all over denominator squared. Okay, any questions with the derivative? Because it's asking to evaluate, let's just go ahead and start plugging in 2 pi for all the x's, right? Let's not worry about trying to clean up. Right? Because as soon as we find a derivative, we can start plugging in and things will start to collapse. Okay, so I'm just replacing all the x's I see with 2 pi. And once I do that, let's see what happens here. So 2 pi over 2 is the same thing as pi. So cosine of pi is -1. If you want to enter this in the calculator, make sure you're in radian mode. 2 stays, this becomes -1, 1/2. Secant of 2 pi, right? So I like to think in terms of cosine. Cosine of 2 pi is 1. So the reciprocal of cosine is secant. The reciprocal of 1 is still 1. 2 sine of 2 pi over 2. So sine of 2 pi over 2 is the same thing as sine of pi. Sine of pi is 0. Secant, and well, anything times 0 is just going to be 0. So I know that as soon as I get 0 here, everything here is just going to wipe out to be 0. And then secant 2 pi is 1. 1 squared is 1. So I'm left with 2 times -1 times 1/2, which is -1. So that's my slope. I'm sorry, 2 pi, not pi. I meant to put 2 pi here. Okay, any questions here? Okay, let's take a look at number 3. Okay, y is equal to 2 sine of pi x minus y. Find the equation of a tangent line. So that means after we find the derivative, we're going to use the ordered pair to find the slope, and then from there, point slope form. Okay, does anybody want to say what's involved here? What methods are involved here?
Implicit.
Yeah, we got multiple y's here, so definitely implicit. What else?
And product?
Okay, so not product rule, not product rule. Now, if it was sine of x times pi x minus y, then that would be the case. But this is a function inside of sine. So it's not as extensive as number 1, but it's still a little bit of a chain rule. Yeah. Basically, anytime we take care of a u prime is called chain rule. So anything that is happening here other than a 1 is going to be chain rule. But yeah, not as extensive as 1, but still a little bit of that chain rule here. Yeah, I want to show you what a product rule would look like, just so you can see the distinction. Okay, now this will be product rule because the sine y will be completely separate from the pi x minus y. Then we have to go through the product rule here. But in this case, the pi x minus y is inside the sine function. So I want to make sure you guys can see that distinction. Okay, product rule here, and this is just one function, so chain rule. Okay. All right, so now we can jump into our derivative step. We know that each time we come across y's derivative, we have to attach a dy dx. So y becomes 1 dy dx. Sine's derivative becomes cosine. So 2 cosine of u times u prime. So the derivative of pi x minus y, pi x becomes pi, and then y becomes dy dx, or 1 dy dx. Hey. So from here, it's up to you what you want to do. Whether you can either start putting in the values in and then solve for dy dx, or you can solve for dy dx first and then plug in the point. I like to plug in the point earlier because then things hopefully will clean up a little faster and less variables are in the way. Okay. But you can solve for dy dx first and then plug in the order pair if you like. So I'm going to start putting in the order pair because I'm already at the derivative level. I'm just trying to get it down to a number here. Okay, so replace x with 1, replace y with 0. Y becomes 0, so just 2 cosine of pi. And then pi minus 1 dy dx. Okay, I'm trying to get this down to a number here, okay, because all the x's and y's have now been resolved. Okay, so cosine of pi is -1. -1 times 2 is -2, so I have 1 dy dx. Okay, if I distribute this through, I can begin to start moving things around to try to get dy dx. Okay, I have 1 dy dx here, I have 2 dy dx here. If I subtract the 2 dy dx over to the left side, I get -1 dy dx is equal to -2 pi. Divide by -1, get dy dx by itself, so I have my slope, my dy dx is just 2 pi. And all the variables have disappeared because I've replaced all the x's and y's with 0. So that's my slope. So I have my order pair. I have my slope. And now point slope form. Okay, any questions? Okay, number 4. Find the derivative for 5x arc cosecant. Sorry, arc secant of 3x. What do you guys see here? What's involved here?
Is there a product rule?
Yeah, this one has product rule, okay? The 5x and the arc secant are the two distinct functions that are being multiplied with each other. Yeah. Okay, we step through our derivative rules. F prime g plus fg prime. You can cancel things out inside an absolute value, okay? We just have to hold on to the absolute value if there is any variable left over at the end of the problem. But if there's something outside the absolute value versus something inside the absolute value, and they're matching, you can cancel those things out. Okay. F prime g plus fg prime, 5x becomes 5. We keep the arc secant. Back to f. And then g prime. So arc secant's derivative is u prime over the absolute value of u times the square root of u squared minus 1. Now notice that even though the 3 and the x are inside the absolute value, I have a clean match with the x's, I have a clean match with the 3's, so I can cancel everything out inside the absolute value. There's nothing that remains, there's no need for absolute value anymore. And finally, arc secant and inverse of secant means the same thing, so these are interchangeable, so I'll make sure we understand these mean the same thing, so you can interchange them interchange those notations at any time. Okay, back page, no questions? Okay, 5 sine of arc tangent of x over 4. Write the derivative as an algebraic expression. All right, first up, what do you guys see?
Is it chain rule?
This is chain rule. Yeah, this is a function within a function.
Does the 5 go on top?
Yeah, the 5 can go with the outside. Okay, so let's find g prime. Sine's derivative is cosine. Okay, we keep everything inside the u value intact. times the inside's derivative, which is arctangent of u. The derivative is u prime over square root of, sorry, no square root, u prime over 1 plus u squared. Okay. So 1/4 x, the derivative of 1/4 x is just going to be 1/4. One plus u squared.
You didn't. Okay, never mind.
Now, what I mean by algebraic expression means no trig. So we have the derivative. It's okay to leave this portion, but this part we have to clean up a bit more. So we're going to turn this trig into an algebraic. So remember the first thing that we did when we were talking about arc trig is we can't use this to populate a triangle and then find the cosine of theta, right? Because this arctangent of x over 4 is basically saying find the cosine of a triangle where the tangent is equal to x over 4. But to find the cosine of this scenario, it's easier if we can get a picture to show up. So we're going to create a picture where tangent of theta is equal to x over 4. So build our triangle. Tangent is what? Where does the x and the 4 go? Any idea? All right, opposite over adjacent, right? So x and 4. Find the missing side, hypotenuse using Pythagorean theorem, a squared plus b squared equals c squared, take the square root. And now we can establish the cosine of this scenario. So the cosine of theta is going to be adjacent over hypotenuse. Okay, so then put it all together. We got the 5. We got the fractional value and the complex fraction. Okay, questions with 5? Number 6. Okay, 2 trucks leaves depot at the same time. Truck A travels east 40 miles per hour. Truck B travels north 30 miles per hour. How fast is the angle theta changing when A is 3 miles from depot and B is 4 miles from depot? So here's the direction of movement here. Truck A and truck B are going away from each other, away from the same starting point. Here's our theta. So one of the first steps is identifying a trig equation that's going to hit all 3 parts that is given to us in the problem that we can use in the problem. So which one is this going to be? Sine, cosine, or tangent? tangent. Tangent of theta is equal to opposite over adjacent. Okay, we're going to find the derivative. But what do you notice about the right side that we have to apply derivative-wise? Not implicit. These are two variables. What happens if you want to find a derivative of a numerator and denominator? Quotient rule. Okay. So, and also with related rates, we're expecting a couple of other derivatives, right? We're expecting d theta dt, we're expecting db dt, we're expecting dA dt. Okay, so tangent becomes secant squared. Okay, quotient rule, right? Okay, f prime, b becomes dB dt, right? Or 1 dB dt. Minus f g prime, a becomes dA dt. All over denominator squared.
Yeah, I have a question. Why is it secant squared?
I'm sorry?
In front. Right.
Oh, okay. Why is it secant squared? We're just following the rule here.
Oh, okay.
Yeah. Okay. So we have our derivative. We know that ultimately this is the equation that we're going to be using to helping us solve whatever variable we're trying to solve for. So let's go back to the problem and see if we can gather all these variables information. All right, so two trucks leave at the same time. Truck A travels east at 40 miles per hour. So what can hold that 40 miles per hour?
dA.
Good. It's the rate of change of A, which is what's happening with truck A, right? Truck B travels north at 30 miles per hour.
So dB
Yeah, dB dt. And notice that these are both positive. Are they positive because we're going right and we're going north? What? Good. The distance of the triangle is increasing because the way that the triangle is drawn, imagine these lengths both increasing. That's why we get that positive treatment. Okay, how fast is the angle of theta changing? So that's what we're looking for. That's our d theta dt. That's our unknown. When A is 3 miles and B is 4 miles. Okay, I think we almost have everything, right? We have almost everything accounted for. The only thing not accounted for is that secant squared theta. So we can get that information if we can populate information from a triangle. So I like to draw a second triangle to populate that information. So we're looking at a snapshot, right? We're looking at a moment in time when A is 3 and B is 4, which means that the hypotenuse must be what? 5, right? A squared plus B squared equals C squared. You can also recognize this as a Pythagorean triple. Right? And so what's secant of theta going to be? What'd you guys say? Yeah, good, 5/3, right? Secant is the reciprocal of cosine, so hypotenuse over adjacent. All right, I think we're ready. Everything that we need for this derivative has now been accounted for, so now we just plug in. Okay, we start with secant squared theta. Highlight what we're replacing here. Okay. dB dt times A d dA dt all over A squared. Okay, I'm going to move that 5/3 squared over. Start cleaning up here. This is 90 minus 160. So -70, right? Okay, the rest can just go in the calculator. Nine over 25 times -70 over 9. Reduce that fraction. Okay, and what's our unit of measure?
Meters per second.
Well, meters would be, if, but we have theta though.
Oh, yeah, so you upgrade it.
Radians. Yeah, radians per, what's the time unit?
Second? Hours.
Hours, yeah. We're going miles per hour, right? So hours. Okay. Any questions? Is there anybody that came in late who wanted to see an earlier problem? I'm sorry? Number 5, okay. Yeah, but that's all I have. If you guys have any additional questions, I'm just going to go over problems that students didn't see before. Yeah, so this is chain rule here. Inside, outside, or outside, inside. Right? We take outside's derivative first, so sine becomes cosine. We keep the inside, and then we multiply it by arctangent's derivative. So u prime over 1 plus u squared. But here it says write the derivative as an algebraic expression, so that means no trig. So we want to get this out of a trig form. So to do that, we're going to create a triangle based off of this. So basically saying, what is the cosine of a triangle whose tangent of theta is equal to pi over, or x over 4? So from that arctangent of x over 4, we can create a triangle with this scenario, where tangent of theta equals x over 4. So tangent of theta is equal to opposite over adjacent. And once we have that x over 4, then we can populate that hypotenuse using Pythagorean theorem. And once we have that x over 4, then we can populate that x over 4 using Pythagorean theorem. And once we have that x over 4, then we can populate that hypotenuse using Pythagorean theorem. And once we have that x over 4, then we can populate that x over 4 using Pythagorean theorem. And once we have that x over 4, then we can populate that hypotenuse using Pythagorean theorem. And then once you have this triangle populated, now you can make a call as to what that cosine of this triangle is. So cosine of theta is now adjacent over hypotenuse. So this expression can now be replaced with this here.
Sure, Annie.
Yes.
Is it good? You're gonna take right now, okay then?
Open notes?
Yeah.
Yeah. Mhm. All right, anything else, guys? All right, I'll hang around if you have any questions for me. Sam, you okay? You see any previous ones?
Just number 4 would start.
Okay. Number 4 starts off as product rule. Yeah. Here's 4. All right, see you soon.